You dislike Picasso's work, but you simply lack the capacity to understand it. That's what an inhabitant of the fourth dimension would exclaim upon seeing the slightly mad canvases of the scandalous Spanish artist, whose full name was Pablo Diego José Francisco de Paula Juan Nepomuceno María de los Remedios Cipriano de la Santísima Trinidad Martyr Patricio Cleto Ruiz y Picasso. A nightmare, isn't it? Just like his paintings appear to most earthlings. This was the preamble to today's video, in which we will try to look at the world much wider than usual. Surprisingly, although we live in 3D space, Earth's inhabitants are unable to see it fully, as this would require impossible manipulations. Many works of world art show attempts to break free from human limitations and imagine what it's like to live in 4, 5, or more dimensions. For instance, Salvador Dalí's famous painting Crucifixion is also known as the hypercube body, since Christ, at the artist's whim, is crucified on the unfolding of a tesseract, a four-dimensional hypercube. The concept of alternate dimensions is also explored in the science fiction film Interstellar. Remember when the protagonist enters a black hole and instead of a singularity finds, well, let's not spoil it for those who haven't seen this amazing film. But let's get back to Picasso. Many suggest that the artist possessed a unique gift for seeing the world unconventionally. Remember his paintings where body parts, facial features, objects, and silhouettes are deliberately and grotesquely mixed? What we see is chaos an inhabitant of the fourth dimension might perceive differently. Looking at the painterly cacophony from the outside, they would appreciate the true beauty of the canvas. Therefore, a key phrase when discussing other dimensions is to look from the outside. Imagine ourselves in a 2D world. All objects would seem to be in plain sight. They simply wouldn't have anywhere to hide. But the problem is that creatures inhabiting this hypothetical two-dimensional world would possess one-dimensional vision. They would only see a strip in the foreground. Our principle of observing reality is built on a similar logic, only one step above the one-dimensional. Humans have binocular vision, that is, both two-dimensional and three-dimensional, but living in a three-dimensional world, we are not able to perceive it as such. We only become aware of the third coordinate when the object is in motion. Imagine a static and a rotating cube. As an example, consider this. Looking at a person from behind, you will never see their face until the subject turns. But if our vision were three-dimensional, upon entering a room, you would immediately notice a cat hiding under the sofa, a 1,000-ruble note hidden in the second volume of War and Peace, and your interlocutor's face simultaneously with the back of their head. Congratulations! After this, you have the right to use the meme, "Now I've seen it all." That's precisely how our world would look from the point of view of an inhabitant of a four-dimensional space. We have a fourth dimension, time, but people take it for granted, having absolutely no ability to influence it, stop it, turn it back, visit the past or the future. The only thing available to us is the ability to count its seconds, but that's not the point now. For many years, four-dimensional space was considered something mythical, incomprehensible, and frightening, like a centaur or a fire-breathing chimera. Later, the continuum was reflected in Einstein's theory of relativity as Minkowski space. Despite this, scientists continue to find it fascinating. What examples, besides those mentioned above, allow a person to most fully imagine what a 4D world looks like? We often resort to analogies with cubes. Follow the logic. A point on a sheet of paper is a zero-dimensional cube. If you connect 2 points, you get a segment, a one-dimensional figure. By copying the same line next to it and connecting the vertices, you get a two-dimensional square. Doing the same with it, voila! We already have a three-dimensional cube, whose properties we can fully understand only when the figure is moving. And what would a cube look like in four-dimensional space? To draw a tesseract, you should proceed as in the previous cases. Place two three-dimensional cubes next to each other and connect the vertices of the figures sequentially. You get something nonsensical. Welcome to four-dimensional reality, although we are only at the beginning of the journey. Let's try to rotate the tesseract. Don't believe your eyes. What in our world looks like a deformation from the depths of space, in 4D space looks like a perfectly ordinary rotation. If someone alive today, let's leave Picasso alone for now, were to gain the ability to act as an inhabitant of the fourth dimension, this superhero could pass through walls as easily as we jump over a jump rope, move in the most anomalous directions, create a mirror image of human organs, and see through things in the literal sense of the word. Those who watched Lars von Trier's film Antichrist might vaguely imagine the meaning of the expression seeing through walls, since they are drawn there with ordinary chalk. But a classic example of spatial play of imagination is undoubtedly Edwin Abbott's novel Flatland. Kasimov considered this work the best attempt at perceiving dimensions other than our own. But one of the most valuable ideas conveyed by the author in an allegorical form is the following. No inhabitant of their own dimension, pointland, lineland, or flatland, admitted the thought of other worlds. With the stubbornness of ignorant darkness, each considered their own dimension the pinnacle of creation and the ultimate frontier of spatial evolution. Doesn't this remind you of anything? Speaking of science fiction writers, H.G. Wells is perhaps the most successful example of writer-predictors. More than 10 years before the appearance of Einstein's famous theory, this literary genius, in the novel The Time Machine, suggested that our world is nothing more than a four-dimensional space-time. He was also the first to mention anti-gravity, lasers, and even parallel worlds in his works. Returning to our sheep, let's ask ourselves, is the tesseract the only product of four-dimensional space that has magically penetrated our world? Oh no, you forget about the Möbius strip, that very symbol of infinity, and the Klein bottle, objects that can be embodied within the framework of Euclidean geometry. In short, the first artifact is nothing more than a strip whose opposite ends are glued together, but one of them is first turned over. The Möbius strip model is used in the production of conveyors, recording systems, and matrix printers. As for the Klein bottle, this container with holes in its walls, the neck of the exotic bottle must be passed through a hole in the body and connected in a closed loop with the hole at the bottom. Such four-dimensional acrobatics. Let's not try to convince you of the multidimensionality of Hilbert's space. Let's just give one more example to conclude. It will help you realize the incredible complexity of the universe. Imagine that we are fish swimming in a very shallow pond. Since our eyes are located on the sides, movement is possible only forward, backward, right, and left. And suddenly it starts to rain. The fish cannot see the raindrops, but they can perceive the ripples from their impact. So, the German physicist Theodor Kaluza suggested that the light oscillations we see are echoes of real waves enveloping the fifth dimension. Even Albert Einstein was shocked by this bold hypothesis. To summarize and reflect the fierce debates in the scientific world about multidimensionality, let's quote Alexander Pope's phrase engraved on Newton's tomb and later supplemented by one of his meticulous critics. This world was wrapped in deepest night, but let there be light, and Newton was. But Satan didn't wait long for revenge. Einstein came, and everything became as it was before. What do you think when you hear about a time machine? Someone immediately recalls the immortal classic of H.G. Wells' novel The Time Machine. And would you like to use this miracle invention? Some would like to look into the past to see our distant ancestors, while others, on the contrary, dream of traveling to the future to find out what humanity will become in a few decades or even centuries. In any case, it all sounds very fantastic, or doesn't it? It's hard to believe, but already in our time, there are thoughts about real ways of time travel. We tried to systematize them and understand how exactly these journeys can be made, and we are ready to share our conclusions with you right now. No matter how hard scientists try to create a time machine, humanity still does not possess this technology. Science simply lacks the knowledge, materials, and most importantly, specialists to succeed in this breakthrough. But who knows, maybe one of you, our viewers, will in the future prove to be not only a great physicist but also a brilliant engineer and designer. Our task is to interest you, to introduce you to the theory. Yours is to absorb this knowledge and, perhaps, after some time, having deepened it, you will become the creator of the first time machine in human history. Just imagine what you can do by bringing people closer to a device about which many science fiction films have been made and many novels written. There are three main hypotheses put forward to explain the process of time travel. The first is related to Albert Einstein's theory of relativity. According to it, a jump into the future is possible only at the speed of light. Time for an object under acceleration slows down relative to those objects that are at rest. Imagine that traveling at the speed of light, you can fly around the Earth 10 times along the equator in approximately 1 second. Let's transfer this theory to a more grandiose scale. You can travel at the speed of light to the Alpha Centauri star system, while we, ordinary mortals, remain on Earth waiting for your return. While you explore the infinity of the universe, we will continue to live our lives, which naturally implies the aging process. For you, only 6 years will pass, but for us, a whole 10. Upon your return to Earth, you will see how everything around you has changed. Your children, if they were, will have grown up, peers will be older than you, and technologies will be even more advanced, but you will be only 6 years older. The second hypothesis is related to long-term freezing. There are some types of living organisms that can fall into hibernation due to lack of food or changes in ambient temperature, and then, after some time, wake up with the same characteristics that the creature had before sleep. Often, the impact of low temperatures is directly related to this process. However, there is a small problem. The human body does not work like that of a cold-blooded reptile or amphibian. Scientists cannot do anything about it yet, so we should wait with freezing. The third hypothesis is a serious task of modernizing our knowledge in quantum physics. Theoretically, by improving our understanding in this scientific discipline, we will sooner or later learn to move information and even physical objects through space in a couple of moments. That's just great, but it's easy to say, improve your knowledge. Ask yourself, is it easy to quickly improve your knowledge in any field? This is a very laborious process that will inevitably take humanity a lot of time. So, we can boldly leave this hypothesis for future generations. It turns out that the first hypothesis seems more plausible. The famous physicist Stephen Hawking had long been developing its connection with time travel. He made several attempts to prove the very possibility of such movements. In his last book, Brief Answers to the Big Questions, published in 2018, he made his last assumption on the solution to this important problem. How high is the speed of light? It is believed that in a vacuum, it is 299,792,458 meters per second, or 299,800 kilometers per second. In air, the speed will be less, but not significantly, although this may complicate the jump in time. It turns out that this jump in time is still better done outside the planet's atmosphere. Now that we know the value of the speed of light, taking into account the environmental conditions in which it is best to start this journey, all we have left is to understand what device can help us successfully complete this mission. The fastest object created by man is the Parker Solar Probe. Its record speed is approximately 300,930 kilometers per hour. It is believed that by 2025, it will be able to reach a maximum speed of 692,000 kilometers per hour. An excellent result for a probe, but still not enough for time travel. Even at this maximum speed, it will occupy only 0.0064% of what is needed. What to do? Of course, turn on your imagination. Let's put aside all the formalities related to the technical limitations of spacecraft, the capabilities of the human body, and some laws of physics. Let's try to get at least 1% of the speed of light. You will have to combine the capabilities of 16 devices similar to Parker. At the same time, they will have to work synchronously and at the limit of their capabilities. To reach 100% of the speed of light, we will need a total of 1,600 such probes. It should also be taken into account that the price of one such probe is $1.5 billion. After simple calculations, we can conclude that the total amount of this project could reach $2.4 trillion. Moreover, no one can even guess how such a colossal device will work. A not-so-favorable outcome of such a launch is quite likely, and considering this gigantic cost, it could become humanity's worst failure in space. What else might we need money for? To attempt to reach the speed of light will require an incredible amount of fuel, and to maintain this speed, this amount must be simply infinite. You won't find gas stations in space, so this is not quite what you need. But let's move on to Plan B. According to Hawking's conclusions, a person can travel in time by deforming space-time. If this deformation occurs, a so-called wormhole arises. Great, but there's more. You can travel both to the future and to the past. It only depends on the type of wormhole. To imagine what this looks like, draw 2 points on a sheet of paper. There will be a certain distance between them. The movement between them of a hypothetical object will take some time, but we can cheat a little to shorten this time. It is enough to bend the sheet and combine these 2 points. That's how wormholes work. According to the theory of relativity, it seems that everything is easy and simple, but it's not. We completely forgot about exotic matter. Before using a wormhole, you must fill it with this substance. Otherwise, no object can even enter its limits. In the absence of such matter, the portal through time and space will slam shut before you try to use it. Naturally, according to Murphy's law, this type of matter is still unknown to humanity. However, no one canceled human imagination. We can well imagine how a time machine would work using a wormhole. The wormhole must be accelerated to a speed close to the speed of light, and then turned back to its original state. It sounds complicated enough, which is why even the best minds of modern science cannot create anything similar in practice. But maybe we shouldn't create a wormhole? Perhaps we have a chance to find something similar in space. It is quite probable, and the chances of finding it are higher than you might think. It is believed that a wormhole, which is another name for a wormhole, is a possible combination of black and white holes. These objects have a strong curvature of space. However, the wormhole does not have an event horizon like a single black hole. We remind you that the event horizon is essentially a trap, a point of no return, after which we can no longer return. Unfortunately, such objects have not yet been discovered in space. Previous theories mainly describe ways of traveling to the future, but wormholes can also breach the past. But again, all this is associated with decades of space exploration and scientific development. What do we have now? How about the fact that we can move to the past without leaving home? Think we're kidding you? Just look out the window at the night sky. You will see light reflected from planets and emanating from distant stars. To reach the Earth, this light travels millions of years. You are not just observing the starry sky. You are seeing it as it was many, many millions of years ago. And while you are looking at the night sky, scientists continue to think about how to make time travel a reality, the fantasy of many generations of dreamers. Attention! This is still the Hubble channel, but the topic of today's video is clearly related to ufology and the myths surrounding this pseudoscience. In particular, you will learn what alien sex is, whether the panspermia theory is justified, and answer the sacramental question. Where are they all? So stock up on popcorn and find a reliable fulcrum. It's going to be hot. Let's start with the last point. Once, the Italian physicist Enrico Fermi, who incidentally created the world's first nuclear reactor, wondered why, during the entire existence of human civilization, we have not encountered aliens and have not detected any intelligible alien radio signal, despite compelling arguments in favor of a densely populated universe. Where are the probes from Alpha Centauri? Where are the advanced shuttles? Where is the feedback? We stubbornly continue to conduct a monologue with the macrocosm, hoping for the truth of the Drake equation and sending greetings into the void. The hope of finding our own kind served as an impetus for the creation of SETI, a worldwide company for the search for extraterrestrial civilizations. The success of this undertaking has been questionable for 60 years. Let's not emulate sects like Alien Witnesses or Seventh-day Adventists, but try to look at the situation as critically as possible. Attempts to prove that aliens exist, to find signs of microscopic life on other celestial bodies, to interpret photos depicting aliens, or to decipher the nature of cosmic signals invariably crash on the reefs of harsh reality. For example, the WOW signal is the most famous evidence of the existence of extraterrestrials to date. It was registered by the Big Ear Radio Telescope on August 15, 1977. The WOW signal is a unique alphanumeric code, 6EQUJ5. It is considered an attempt by some civilization to contact Earthlings. Presumably, the radio pulse came to us from the constellation Sagittarius. Well, is it real? Not quite. Just a bunch of fantasy and far-fetched facts. Fast radio bursts have long occupied astrophysicists, and their origin is attributed to the explosions of neutron stars, pulsations of magnetars, the transit of comets, and even traces of the activity of starships. But alas, no matter how hard astronomers have tried to catch the WOW signal again, they have been unsuccessful. The vast majority of scientists believe that the so-called radio evidence of the existence of aliens is nothing more than a reflection of fragments of space debris or a microwave oven turned on at the wrong time on the territory of the observatory. This means that the signals are the result of misinterpretation, and aliens are a silly myth. Then let's ask directly, did you really look everywhere? Everywhere humanity can reach so far? But first of all, Mars was chosen as a springboard for the search. Humanity still sends armadas of probes to it, experiencing a maniacal desire to find evidence of past or present life. Moreover, some persistent individuals, such as the English writer and futurologist Sir Arthur Clarke, tried to discern unusual features on the red planet. In 2001, the Briton took a NASA image and began to claim that vegetation was rampant on Mars, which clumsy probes were unable to see. Predictably, the loud statement turned out to be a fake. What you see in the photo is just sand dunes crowned with caps of frozen carbon and no Martian landscape designers. It's reassuring that Clarke didn't emulate Charles Cross, who proposed to make a cyclopean mirror on Earth and burn a message directly onto the surface of Mars, or the mathematician Gauss, whose idea was to sew a significant part of it with a wheat triangle illustrating the Pythagorean theorem, so that the Martians could admire the collective earthly mind. In other words, here too it's an empty hype without concrete results. Could it be that during the existence of humanity, not a single real piece of evidence of the presence of aliens, or at least attempts by aliens to contact us, has remained? We will bypass the pyramids of Giza. Where are they hiding? In such oceans, on super-Earths, in wormholes, or in dark energy clouds? There is no answer yet. Let's turn to the appearance of humanoids, as they are commonly called in the circle of homegrown ufologists. The information varies greatly. Some describe a humanoid creature of enormous height, others, green pygmies with large heads on thin bodies. In pseudoscientific ufology, aliens are called greys. They are most often mentioned by eyewitnesses and appear in science fiction films. The most high-profile of the oral testimonies of the earthly activity of UFOs appeared in September 1961. On this momentous day, the abduction of the century took place. Betty and Barney Hill were returning home in their Chevrolet in the evening. They were driving from Niagara Falls and were very cheerful when, according to the laws of the genre, Betty saw a sparkling point moving chaotically across the velvet of the night sky. It is clear that insidious aliens kidnapped the couple and, after poking around in the brains of the Americans, released them. After that, Betty started having nightmares, and the couple turned to a psychiatrist. Interestingly, when Betty was hypnotized, the stories of the husband and wife about aliens with pear-shaped heads who examined them in a strange room aboard a flying saucer largely coincided. That's good news and bad news. The description of the aliens was painfully similar to the characters in the TV series The Outer Limits, which aired a couple of weeks earlier. But there was also material evidence, a star chart indicating the point from which the aliens came and their appearance. Rather, Betty described what the scheme looked like. Amateur astronomer Marjorie Fish recreated the star atlas in reality. Be careful with the jokes. For ufology adepts, this artifact is like the Bible for Christians. In any case, it was later revealed that the map was inaccurate, the regressive hypnosis method is unreliable, and the incident itself is extremely improbable. Let's rephrase the famous expression from Gorky's novel. Was there contact? Perhaps there was no contact. But no matter how little evidence of extraterrestrial civilizations we have at our disposal, theories of the origin of humanity directly related to space are still being considered. And so we come to panspermia, a hypothesis that states that a long time ago, the Earth was seeded by someone. In other words, humans are the offspring of aliens. And that's quite possible, since some biologists attribute parts of our DNA to extraterrestrial origins. The idea of panspermia was first voiced by none other than the Athenian philosopher Anaxagoras. It was too crazy to find followers. Only after several centuries did Hans Richter support the theory. But here's the catch. No matter how much scientists searched for these seeds on meteorites, disappointment always awaited. Either the interpretation of what was found was incorrect, or the microorganisms turned out to be terrestrial. So, we're missing the mark here too. For dessert, let's mention the hottest topic promised at the beginning of the video: sex with extraterrestrial beings. If there are so many aliens on Earth, as eyewitnesses say, then it is logical to assume that we could get closer. In 1930, a skull of anomalous structure was discovered in Mexico. According to ufologists and other supporters of the extraterrestrial conspiracy, the skull belonged to the product of love between a human and an alien. Such are the things. Of course, embarrassed pseudoscientists usually add that there might not have been passionate love, since representatives of extraterrestrial civilizations almost certainly possessed the technology of genetic intervention at a distance. In any case, after some time, real scientists, using the analysis of mitochondrial DNA preserved in the bones of the alien offspring, determined that the skull belonged to an ordinary child born with a severe pathology, hydrocephalus. It would seem, what else is there? To not undermine your faith in humanity and its enlightened minds, we won't even try to indicate the statistics of people who believe that they were abducted by aliens exclusively for sexual experiments. In short, while we were preparing this video, not a single alien indignantly refuted our lies and did not wish to become a consultant. From this, we draw a sad conclusion. The rumors about Area 51 are greatly exaggerated. Most of us have been familiar with the number 0 since elementary school. We know what this number looks like and understand that dividing by 0 is impossible since it does not correspond to a specific quantity of anything. But absolute 0 is not like that. Several decades ago, its definition was simplistic. You can't. But with the advent of the era of quantum mechanics, everything changed dramatically. In a simplified form, the definition of absolute 0 comes down to its temperature indicators, significantly different from the classical freezing point of water. According to different scales, they are minus 273 degrees Celsius, minus 459.67 degrees Fahrenheit, or 0 Kelvin. In the natural terrestrial environment, these indicators have never been reached. The minimum temperature ever recorded on the planet was recorded in Antarctica in 1983, slightly above minus 89 degrees Celsius. But in deep space, mega-cold locations do exist. For example, the Boomerang Nebula, located 5,000 light-years from Earth in the constellation Centaurus. According to the latest data, its temperature reaches absolute 0 and is equal to minus 272 degrees Celsius, or 1 Kelvin. The nebula, similar in shape to a boomerang, is considered the coldest place in the universe. The temperature within its boundaries is lower than the relic radiation emitted during the Big Bang. By the way, we were distracted. Why is the mentioned temperature threshold called absolute 0? How do usual things behave at this extreme temperature? What gave rise to the Boomerang Nebula, which possesses such an anomalous temperature? Traditionally, we will start with the last question. Before explaining the complex algorithms of the appearance of amazing objects that do not fit into the framework of traditional physics, let's resort to a specific example. Let's conduct a simple experiment. Extend your hand at a distance of 10 centimeters from your mouth, take a deep breath, and blow on your palm, pursing your lips into a tube. What do you feel? Of course, the air that touched the palm will bring coolness. That's how we cool a child's wound, or try to cool down hot soup. Now try blowing on your palm with your mouth wide open. Do you feel hot air on your hand? Do you think a miracle happened? No magic, just ordinary physics. Initially, the air temperature is the same, but when it slowly passes through a wide opening, it heats the hand. But exiting through a narrow slit, the stream rapidly expands and cools the palm. According to astronomers, the Boomerang Nebula was formed in approximately the same way. Its appearance was facilitated by hot stellar gas, which was instantly ejected from tiny openings, thereby cooling down to the borderline temperature. And so we come to the ambiguous concept of temperature. We know everything and nothing. Everyone understands what cold and hot are and periodically monitors the street thermometer, but the patterns of the process are not fully understood. To explain simply, temperature is directly related to the movement of atoms and molecules. This is evidenced by the molecular kinetic theory. The more dynamically they move, the higher the mercury column rises. Thus, it is not difficult to guess that there must be a lower limit when the molecular motion becomes completely zero. This is absolute 0. But, as mentioned at the beginning of the video, quantum theory made adjustments to this definition. Modern research suggests that atoms do not completely stop. They come to a state of oscillation without releasing energy, zero-point energy. Meanwhile, these corrections do not affect the borderline low temperature of the substance. It remains minus 273 degrees Celsius. Can matter reach a state of absolute 0 in reality? The third law of thermodynamics states that under no circumstances is it possible to approach absolute 0 arbitrarily closely. it is impossible to reach it. This paradox can be compared to attempts to overtake light. In cryolaboratories, experiments of this kind have been repeatedly conducted, and at present, scientists have achieved freezing to a few billionths of a degree above absolute zero. But the peak of -273 degrees Celsius has not yet been taken, not even by the Boomerang Nebula. How do substances behave at extremely low temperatures approaching absolute zero? Very extravagantly. Even those who have not studied physics, looking at the behavior of familiar objects at near absolute zero, will be taken aback, for life experience will tell them that something is wrong here. For example, many materials acquire superfluid properties, completely getting rid of viscosity, magically arranging themselves in ultra-thin layers, and easily getting out of any containers. In such conditions, the concept of a superconductor arises, completely devoid of electrical resistance and allowing objects to achieve levitation, overcoming the force of Earth's gravity. Only under conditions close to absolute zero is it possible to create a unique Bose-Einstein condensate. Most of us are only familiar with the four aggregate states of matter: liquid, solid, gas, and plasma. But the Bose-Einstein condensate refers to a fifth category, possible only under conditions of total cooling. In such a state, bosons can exhibit quantum effects, in particular, wave-particle duality, becoming simultaneously a particle and a wave. Only the properties of helium remain unshaken. In the family of chemical elements, it remains liquid even at -273 degrees Celsius. Nevertheless, it is obvious that the world under conditions of absolute zero would differ radically from what we are used to. If there are borderline low temperatures, then there must certainly be a limit of hellish heat. It turns out that no, at least at the moment, experiments in this area in terrestrial conditions are impossible. Therefore, scientists consider such a threshold unattainable. Let's try to reason logically. If temperature is interconnected with the movement of atoms, then it can be assumed that having accelerated to the speed of light, they will reach that very maximum. After all, it has been proven that no particle in the universe flies faster than photons of light in a vacuum. This means that this is the ultimate heating temperature. If everything were so simple, in quantum physics, there seem to be no accessible and easily explained concepts. Let's assume that we have an ideal heater with unlimited capabilities. At a temperature of several thousand degrees Celsius, any substance would turn into a gas, then into plasma. Further, reaching a mark of billions of degrees, nuclear transformations would begin. At trillions of degrees Celsius, the world would be populated by exotic particles such as mesons, positrons, baryons, and others. At this point, the experimental limit would be reached, but the laws of physics do not prevent the temperature from rising further. Upon reaching quadrillions of degrees, amazing things would begin to happen. The masses of elementary particles would tend to zero with each millisecond, and more new varieties of them would appear. The apotheosis of the process would be the Planck temperature, whose value is septillion times greater than the heat of the solar core. Under such monstrous conditions, space itself would boil, since the scale rises to 10 superscript 3 superscript 2, a unit with 32 zeros. What would the universe be like at higher temperatures? Modern physics cannot predict this. Scientists have been struggling for more than a year to build a theory that reconciles gravitational effects with quantum mechanics, but so far without success. Summarizing the above, it can be stated that we are much closer to absolute zero than to the Planck maximum. It is also clear that the world we are used to is difficult to imagine at exotic temperatures, and in some aspects, simply impossible. On May 30, 2020, the whole world watched an event whose importance for the global space industry cannot be overestimated. We became witnesses of a breakthrough achieved through the joint efforts of NASA and the American company SpaceX, owned by the billionaire and philanthropist Elon Musk. For the first time in the history of space flights, the private company SpaceX sent 2 NASA astronauts to the International Space Station. A definitive victory of capitalism, not only for NASA and the United States. The launch of the spacecraft was the first since 2011. Let us recall that after the closure of the American Space Shuttle program, their delivery was exclusively handled by Roscosmos using Soyuz rockets. Let's follow the chronology of this important launch together, but before that, let's learn something about the unique means of delivering these astronauts to the ISS, a reusable crewed spacecraft called Dragon 2, or Crew Dragon. So, what is the infamous Dragon number 2? It's an almost completely autonomous marvel of engineering that took off thanks to the Falcon 9 rocket, capable of reuse. The spacecraft is designed to deliver 4 to 7 people into orbit. Unlike its earlier cargo version, Dragon 1, Crew Dragon is capable of docking with the ISS independently without using the station's manipulator. According to the creators, thanks to the Super Draco engines, the spacecraft is capable of landing almost anywhere with the precision of a helicopter. The ability of a controlled landing is maintained even with the failure of 2 of its 8 engines. In case of engine failure, the landing is performed on parachutes. Super Draco engines are the first engines in the space industry whose manufacture is possible using 3D printing technology. One of the most significant differences between Crew Dragon and the Russian Soyuz is its crew escape system. In the American spacecraft, it is internal, integrated, while in the Soyuz it is external, based on ejection. What are the advantages of the new approach? An externally ejected part of the escape system will always be dead weight at launch, while an integrated one can use fuel intended for maneuvering. It turns out that the fuel is not wasted. It's a solid win. You can also look at the futuristic design of the spacecraft's interior. Large panoramic windows, touch screens in the cockpit, and beautiful spacesuits for the crew, developed by SpaceX with the help of the famous designer Jose Fernandez. We are sure that you have watched at least several films featuring costumes created by this talented person, including Tron, Legacy, Oblivion, and superhero films in the Marvel and DC universes. Initially, the first crewed flight to the ISS was planned by NASA and SpaceX back in 2017, but in the last 3 years, Crew Dragon failed critical tests several times. Do you think this could have disappointed Musk and his brainchild? The answer is obvious. After numerous redesigns of the structure and lengthy adjustments of all systems, the launch was just around the corner. Millions of people who followed the historic event were disappointed by the cancellation of the launch on May 28. NASA Administrator Jim Bridenstine stated that the launch of the spacecraft was postponed to May 30th due to weather conditions. Finally, Crew Dragon, carrying 2 NASA astronauts, Robert Behnken and Douglas Hurley, to the ISS, launched on May 30, 2020, at 1922 from Launch Complex 39A, located at the Kennedy Space Center in Florida. Known as the SpaceX Demo 2 mission, the entire flight is a full-scale test of crew transportation systems, including launch, orbital insertion, docking, and landing. This is the second test flight of the Crew Dragon spacecraft, but the first with a crew on board. Behnken and Hurley were able to successfully test the performance of the spacecraft's internal systems, as well as the low-thrust engines during maneuvers on approach to the station. The astronauts took control of Crew Dragon to test manual control of the spacecraft. This is an absolutely necessary procedure because in the event of a problem with the automatic flight of the spacecraft, the onboard crew should take over. On May 30th, the crew checked the roll, pitch, and yaw of the spacecraft. The first docking maneuvers began on May 30th at 16:09, and the spacecraft began a direct approach to the ISS around 8:27 on May 31st. Despite the fact that Crew Dragon is equipped with an automatic docking system, the crew constantly monitored the operation of all involved systems and switched control to themselves to check all its capabilities. The spacecraft docked to the American segment of the ISS on May 31, 2020, at 14:26. The NASA news agency provided a broadcast of the entire path that the Crew Dragon crew traversed to the orbital laboratory. After successful docking to the ISS module called Harmony, the Crew Dragon crew joined the friendly team of Expedition 63 of the International Space Station. What awaits the astronauts next? The crew used for this flight test may remain at the orbital station for about 110 days. The exact duration of their return flight will be determined at the station based on the readiness of the next commercial crew launch. However, it is too early to speak of the final success of the mission. Why? In addition to minor communication problems with Earth that occurred during the flight, the astronauts still have their return from orbit to the surface of the planet ahead, and this process is very often accompanied by unplanned situations. It is planned that upon completion of the mission, Behnken and Hurley will return aboard Crew Dragon, which will then independently detach from the ISS, leave the limits of the space station, and re-enter the Earth's atmosphere. After splashdown in the Atlantic Ocean off the coast of Florida, the crew will be picked up by a SpaceX rescue vessel and returned to the dock at Cape Canaveral. It can already be said that the practical benefit of Dragon 2's success for the International Space Station, and therefore for world science as a